All right, can everybody hear me? Starting a few minutes late, so I'm going to go ahead and get started. I've got a lot of material. I think I can get it in under the wire so we don't cascade the delay. I'm Logan. I work at Square. I'm here to tell you a little bit about some of the techniques that we use to manage the complexity in our Android apps, how we build understandable apps that are sort of easier to build and test, and sort of also how we dug ourselves into a hole and how we got back out. Really, it's kind of mostly about bagels and this one crash. This is the crash in question. Crashes are familiar, so I figured we might as well start here. This is an exception that occurred in Square Register, which is kind of our flagship app. It's a Stack Overflow error, which you tend to see when you get your recursion wrong, but we managed to do it the easy way. And if you look down at the bottom, a few lines from the bottom, you can see exactly how. This is happening during the drawing of a view group. View groups are hierarchical, and the hierarchy is drawn from the top. Every view group draws its children, and it's a depth-first process, and it just sort of cascades down your hierarchy until it's ready to put everything on the screen. Our hierarchy is very, very, very deep. I've highlighted here all the calls to draw child, so you get an idea of how ridiculously deep our view hierarchy is. It's something like 22 nested view groups before we try to draw the thing that presumably blew up, but maybe we were going to keep going. We don't really know. And the funny thing is, this is the screen that crash occurred on. It doesn't look that complex. We've got a list view in the search field and some other stuff, a toolbar. Looks pretty flat, actually. So how did we end up with this crazy Stack Overflow? To understand that, you sort of have to understand how we built all our screens. Like everything else, this screen started its life as a composition from our designers. They did a wireframe, they filled it in, they gave us a Photoshop file, they gave us some specifications, but it was just a flat image and we had to turn it into something live. In fact, they gave us a lot of these, and being good designers, they tied them all together into a nice flow that sort of related them all to each other, so we could see how the information was all related and how you would navigate through the application. In Register, it ended up looking sort of something like this, where you have a home screen, you've got some settings that you can go tweak from the home screen, or you can instead go to look at, for instance, your items. These are things that you would sell to a customer. Here, you're editing them, and you might have a couple of items like a bagel or a croissant, which are basically the same screen, but they're different things, so you drill in from different rows in that list. Pretty straightforward. And we're going to have a bunch of information on each of these screens, obviously, and this is the way we think about it. Like, when you're on the items list screen, you want to have the items list, and when you're on the bagel screen, obviously, you need the bagel and whatever bagel-related services you may need in order to properly edit the thing. Of course, this is Android, so views, even the activity, can be torn down and rebuilt. This happens for a variety of reasons, as we're all familiar with. You go to the home screen and back, you rotate the phone and it throws away the entire world on you. And we don't want this to happen to our information, our actual bagel and our actual bagel-related services. So we can't just stick them in the view, and we can't just stick them on the activity. Instead, the common solution to this is you stick them on the application. And the reason you stick them on the application, as we all know, is the application lives as long as the process does. And Android has some mechanisms for persisting information that needs to live longer than the process does. But for the most part, this is how you deal with things. You keep them in memory by making them singletons on the application. Unfortunately, this is basically just a global, right? It has the same problems that globals have everywhere. Your bagel is going to be held in memory all the time, even if you're not looking at your bagel. If your bagel has any shared state, if it's mutable, if you've got toppings or different schmears or like whatever you want to put on your bagel and you've been messing with it, well, it's entirely possible somebody else can come and change your toppings while you're not looking. And of course, if there's anything that runs that keeps the bagel updated as someone does choose toppings or whatever, say you're actually selling it at some other location and somebody sells your last bagel, you're going to have things actually mutating state because you have live objects held as singletons. Don't want that either. That's how you get bugs that you can't even see. Plus, if we put everything there, our application just kind of turns into soup, right? Like we put our bagel up there, we put up our croissant, we put up everything, and it just turns out you've got a giant mess filling up your application. So globals are bad, except when they're not. Like we do want some globals, right? We want probably a user because we have one user logged in at a time, and it's useful to have information about their session. We want to have some representation of our server. You know, this is like our retrofit interfaces or whatever. We want to have a database that we can pull stuff out of, you know, where the bagel lives when we're not touching it. But the rest of our stuff should all be tied to a screen or to some subset of screens. You know, the items list, as I said, we want to have when we have the items list. We don't necessarily need it on every screen. We don't need our bagel on every screen, but sometimes we do. So we have a really simple goal here. We want a screen. We want to put the bagel on it. We don't want all that other junk floating around. Pretty straightforward, but remember, we ended up with this mess somehow. So how do we get here from just trying to put a bagel on the screen, and what do we do about it? Good news is this is the part of the talk where we start answering questions instead of asking them. So we wanted to avoid this problem of an application soup where we just fill up the app with singletons. Our usual answer to, you know, not having just a big floating mess of soup is that we structure things. We structure them into trees. That's the way that we think of composition and decomposition. It's just a natural thing that humans do. So why a tree specifically, though? Because we want that scoping, right? We want to be able to set up and tear down different parts of it when we're not using them. And we do have some things that are going to be used in more places than others, and we want to share those. So back to the bagel and getting the view of the bagel. How do we do that? Android has this awesome thing called a context. Every view has a context. Every view has access to one. And it's pretty familiar to everyone in this room. This is where you go to get your layout inflator. It's where you go to get your notification manager, your window manager, all of the, you know, system manager things. Context refers to them as system services. And really, it's just a thing where you can give it a name, and it'll give you back the thing associated with that name. It's just a map, right? So maybe we could have a bagel system service. Get system service bagel, gives us back a bagel. Great. It turns out we can. Android provides composition in the form of this context wrapper thing. So we could actually build a bagel context that wraps the system context, right? And if we ask it for a bagel, it'll give us back a bagel. And if we ask it for the layout inflator, it'll go, well, I don't know how to get the layout inflator. Let me ask the guy you wrapped me around. Maybe he does. And so on. So we can compose these things, right? We can wrap them around each other. That's all well and good, but we need to make sure that when our bagel view calls get context, it gets our bagel context, not the one that knows about the layout inflator, but not our stuff. There's a clue here in activity. Activity is an extension of context theme wrapper, and if any of you were at Dan's talk yesterday, this is going to be pretty familiar to you. The context theme wrapper holds a theme, but it doesn't expose it as a service directly, right? It just embeds the information that was read out of the manifest as it was configured for your particular activity. It has exactly one service that it knows how to provide, and that's the layout inflator. So you ask a context theme wrapper for a layout inflator, and instead of just giving you the one that its base context has, it gets that, and then it wraps a new instance around itself and gives you that. So you get instead a layout inflator that now knows about the theme information because it can get it from the context. So this is how the activity gives the views the right theme from the manifest. They're all inflated with a context that embeds the theme. Long story short, inflator plus context gives you view. You can also, of course, construct a view directly, but life is a little bit easier if you just use the inflator, so we want to take advantage of that hook. Of course, this is silly, right? Like, if we just made a bagel service, then we'd have to start making a croissant service and a sandwich service and everything, and it's the same, ends up being the same soup. We've just moved it to the context and added extra boilerplate and made it weird for everybody. So instead, we embed our dependency injector, right? How many people in the room are familiar with Dagger? OK, pretty good. For those who aren't, Dagger is a dependency injector. It's exactly the same thing as context, but it's inverted, right? So you give it a thing that has a bunch of dependencies that wants stuff, and that thing is all marked up with the stuff that it wants. And Dagger goes and finds the stuff that your thing wants and gives it to it. So it's basically, under the hood, it actually kind of is context. Dagger is essentially a map of names to things, right? So this is a simple way for us to get that same soup and get it organized for us, because Dagger's whole job is to organize soup. So the object graph that Dagger provides us, and this is the thing that does the injection, this is the thing that actually contains all of our objects that we're interested in, is configured via these things called modules, which aren't that important except to say that they configure a particular object graph. And the really cool trick here is that Dagger object graphs can extend or wrap another object graph. So I could have a module for my bagel. I could have another module that has my database in it, and I can wrap the bagel module around the database. And if I ask that object, the resulting object graph for the bagel or the database, I can get them, right? So it composes. It composes the same way the context does. So now we can essentially just make Dagger our system service, and we can get whatever we want out of it. And we avoid the soup in the application. We've moved it to Dagger, where we can manage it more easily. OK, so now we can back our screens with different parts of the model. And remember, the model is a tree. And what about our application-wide stuff? You know, our user, our database, the kind of stuff that every screen in the app really does need. We don't want to have to like duplicate that all over the place. In fact, if we did, we'd be in real trouble, right? You don't want a different database backing every screen, and you don't want to tear down and reconstruct your database every time you move around. Well, conveniently, application's already a context wrapper, which means it has a get system service that we can override. So we can do the same trick, right? We can put our database and our user and whatever in the context that is the application. We can keep it in the application and have a very small bit of soup that everybody can reach into. We can also keep that organized with Dagger, and we do. Incidentally, so is service. Now, this is not the system service, obviously, that context refers to. This is the background-y stuff that you use when you want to do something headless or respond to intents or whatever. It's not really interesting for the purposes of this talk. We want to focus on the UI mostly, so we're going to ignore it from here on out. Just remember that some of the same stuff applies. Anyway, our view has a context. That context essentially is the activity, which embeds some more information, and it wraps the application. Put another way, you know, you've basically got these nested shells of things that can all delegate inward. So when the view asks for something, it can get it from the activity or from the app. Another way to look at this is that your application's contexts form a tree, right? Same thing. Because of the inward delegation. You could think of the inner things as being the parents of the outer things. And we can hang our stuff on that tree. And the really fun thing is that we know that view hierarchies are trees. So we can replicate this trick as much as we want, right? In fact, in register, that's what we did. As we added levels of abstraction and of scoping and more things that we wanted shared more or less broadly, we added enclosing frame layouts to accommodate those things. Each frame layout would hold a context, which held some stuff. In this case, you know, seller and items are frame layouts. Bagel is probably the actual layout that you saw that, you know, shows the bagel and stuff. So we end up with a view hierarchy that's really kind of one-to-one with the tree that we built our model and our application into, frame layouts. Our app, of course, is not static, right? We need a generic view container because we're going to be doing this all over the place. As you saw, there's lots of nesting. We only want to write that container once. And we need it to support navigation. And remember, the whole point of scopes is we don't want to keep everything in memory all the time. So if we have all the stuff that we need to see the bagel screen and we decide we want to go see the croissant, we need to throw away the bagel, build the croissant, wrap it up in a context, inflate the view, and we're good to go. The items container here, this frame layout, actually does all of that work for us. And so we can nest those frame layouts, and they know how to do this recursively, essentially. And when it's all done, we're on the croissant screen. We have a croissant screen view wrapped around a croissant context. If we want to go to settings instead of a croissant, we need to tear down a couple of layers of hierarchy, because now we don't care about our items at all, right? We just want to see our settings. So the seller container knows how to do that. It knows how to switch between items and settings. So the way this works is on the croissant view, we essentially say, I'd like to go to settings, and it dispatches upward until somebody says, I know how to do that. And then the actual construction happens downward. So the container that knows how to work its way back down to the place you're trying to get inflates a child, and then hands it off and says, you show the thing, inflates a child, hands it off, etc. So let's take a break from this weird hierarchy thing and talk about how we specify and invoke the move, right? Our primary trick here is that we identify every screen in the application using a value object. Value object being something just, really simple, really immutable, has just enough information to identify where you want to be and what you want to be showing when you get there. In our case, the type is usually enough information to denote what you want to see. The home screen is the home screen. You're done. If you say go there, you go there. Notice, though, at the bottom, we have this item ID thing on the item screen. That's because, if you remember, like our bagel screen and our croissant screen were basically the same thing. They were just showing different data from the database. So we parameterize it, make that part of the equals hashcode contract, whatever. The important thing to remember is that some screens are actually parameterized, including this item screen. OK, so we now have a way to specify where we want to be in the application. We need to turn it into our actual scopes. So we have a factory that takes a base context, takes the screen. It's going to fish the Dagger object graph out of its base, right? So if the base is the application, for instance, this is going to be the object graph that contains your user and your database. It's going to look up the module for the screen. So maybe it's the settings module, and it's got all your settings stuff in it. This configures all the objects for actually modifying settings. And it's going to wrap the latter around the former so that you get a new object graph that knows how to provide you all of those things. And then we just pack it up in a context, and then we just need to get it to our view. And we get it to our view by doing the same layout inflator trick, right? Same thing context theme wrapper does, where it embeds the theme. We embed an object graph instead. So we end up with these nested scopes of our model and our business logic, and they're bound into these contexts. And that all gets built recursively as we recursively build our view hierarchy when we navigate. We have container views that do all of this work of actually building the context, looking up the objects we need and packing them, and then building the view hierarchy and swapping views around. There's one more thing those containers can do for us, which is great. They're containers. They're there. We might as well use them. Notice we have this toolbar at the top of both screens. When we change screens, we just want the stuff below that toolbar to slide around, right? But we want the toolbar to remain fixed in place and just update for whatever the new screen content is. Conveniently, we have this items container already, so we just build the toolbar into the items container. We put a controller for that toolbar in the items context, which, remember, all of its children are going to have access to. And then each of these screens, the item list screen and the croissant screen in this case, are going to have access to that toolbar, and they can configure it as they need to. Incidentally, this was actually the pattern that first led us to doing this sort of view swapping approach. Years ago in Square Card Reader, before fragments were a thing, and then, of course, we did this with fragments because we had an action bar in Square Card Reader, and we wanted to move stuff below it, and we couldn't figure out any other way than to essentially have a container where we swapped views out underneath. So we consolidated a bunch of activities into one, and the activity was there basically to hold the action bar. So that's nice, actually, because this is now meshing with things that we've been doing for a long time. So at this point, right, all of our trees are aligned. We have a view hierarchy, which Android gives us. That's a tree from the platform. We have an informational hierarchy, which is given to us by our designers and by ourselves, because we actually have to reify that stuff into something that we can work with. And then we have this navigation hierarchy, which again came from the designers. And they're all sort of tied together, and they're all one-to-one. We have container views, of course, for the scope and to share elements. And we built a few apps this way. We built an app called Square Order. The first version of that was built this way. Square Cache is built this way. Works perfectly well. It's great. Register is built more or less this way, and it also works great, except when we start seeing this kind of thing. So why are we seeing this kind of thing in Register? You might remember this thing from PY's talk yesterday. This is the scalpel view, right, where it sort of just explodes all the layers of your view hierarchy and shows them to you in all their gory, horrible detail. Register is really complex. It has a lot of view hierarchy depth already. There are a lot of reasons we actually choose to nest views. And then we're also piling a lot of view hierarchy on top so that we have that one-to-one mapping with our scopes, with our model tree. And eventually, we keep doing that. We run out of what turns out to be a limited view hierarchy depth. We just hit bottom, and the app blows up. So we'd like all of this to scale better, right? So let's see what we can do. As you now know, this is a dramatically simplified view of our hierarchy. Enough to get the idea. We have a few levels of frame layouts that do nothing but hold context and participate in navigation dispatch. We're going to get rid of those. To recap, we want a context that looks like this, and we want to create a view with it directly. So remember our screen classes. The thing I didn't mention about the screen classes before is that they're also hierarchical. If you look closely, you can see that item extends items, extends seller, extends screen. This makes sense because we have that hierarchical navigation. We need to encode the hierarchy in each of our screens. So the bagel instance, for instance, wow, instance twice. The bagel item screen encodes not just that it's a bagel and that it's the item screen, but all of the parent scopes as well. One way to think about this is that it's sort of an absolute path to the screen. It's not, of course, we're not actually mapping strings here, although we could. It's just that the path is implied, it's encoded in the screen instance. And we want to do it without inheritance because composition's better than inheritance. We have a couple of books that promise us that, and so far it's worked out. So here's the basic idea. We rename the screen to path because it's kind of like a path. It's a little easier to understand that way. And then we give it a way to build an absolute version of itself that's very clear. So if we ask item, where are you in the app, we get the full path to this item. The whole thing flattens, in other words, and we can essentially take our context factory, give it just this item thing, and have it turn into our nested context of scopes. So this is really important, actually, because this is how we're going to clean up this whole mess. We're going to build the context in one go, no matter how complex it is, no matter how deep it is logically. So we don't need a view hierarchy and recursive navigation anymore. The activity instead can just build the context of whatever depth needed, inflate the item view directly, and attach it to itself. Navigation, of course, is a lot simpler when you don't have to do all this recursive moving around up and down the tree. The activity can just swap the views around. So we've taken this approach, this flatter approach, in the second version of Order, in the Caviar app that people order food with, in the Courier app that we give to Caviar couriers, and we're also applying it to Register to break up those Stack Overflow errors. A couple of advantages to that approach. We get to keep our informational model in a tree. It's nice, right? So we're still using context wrapper and get system service, and we're still nesting context. We've removed all of the extra depth from our view hierarchy, and we have one container that uses layout inflator cloning context to embed that context in the view. And we simplified our navigation mechanism. In fact, we simplified our navigation mechanism kind of a lot. Let's look at this screen change. Remember, we pulled the shared toolbar up to the items container before because we only wanted to watch the content below it move. We wanted the toolbar to stay in place. But now the toolbar is kind of the only reason we even have this container. Fortunately, we have transitions now. We can make each screen a complete screen with its own toolbar. And our transition will capture the toolbar from each screen. It'll capture the content from each screen. And it'll provide the illusion of a single fixed toolbar that's separate from the sliding content, simply by grabbing the incoming toolbar and putting it on top of the outgoing one while it slides stuff around. Broadly speaking, we can control everything about how this animation plays. And we can do that for any of our screens and for any transition between any of our screens. So it's a great approach, right? We get much finer control over the animations. We don't have to share control of that toolbar between its children now either, right? So there's no shared mutable state on the toolbar, no weird glitches where like somebody forgot to update something. And the toolbar itself gets a lot simpler because we can split it out into two views, each of which just have the one layout. They're not reconfiguring themselves, and they're not doing fancy stuff. The only problem with transitions is they didn't show up until KitKat. So I know a lot of people are thinking, you mean Lollipop, right? No, Lollipop. So Lollipop applied the transitions that arrived in KitKat to activities, which is pretty cool. But they're there in KitKat. You can use them for views. The good news is we can also do a lot of the same things with just animators, especially now that we have this single container. So our applications support all the way back to Ice Cream Sandwich when we got this nice new animator framework. The animators are a little simpler. They can't really do the fun stuff. They're not quite as easy to write, but that's okay. We provide some basic animators to fall back on, and people with new devices get flashier stuff. So one more quick look at that navigation container. Anytime the app wants to change from one screen to another, that change goes through here. That means we can inspect the paths that are changing here, and we can use what we find to control how the change happens, whether it happens, and apply side effects. We can do all kinds of cool stuff, and it all happens in one place, so it's easy to understand, it's easy to find, it's easy to configure. For instance, the Caviar Courier app has this incoming order dialog. I'd show you the actual dialog, but it's not actually important. It's dialog. It shows up when an order comes in. This is my favorite part of the talk. Over time, I've sort of annotated this thing a little bit. I might have actually deleted a couple of annotations so it would fit on the slide. I'll walk you through them. So the first one is the layout. It's, how does the navigational controller construct the incoming view? And remember the layout inflator trick, it just does that. The second one is dialogue. This tells the navigation controller this is a dialogue, and it tells it essentially which animations are you going to use to show this thing. Are you showing a dialogue after not showing a dialogue? Are you dismissing a dialogue? Are you going from one dialogue to another? Either way, that can all be looked up at navigation time just by looking at this annotation. I originally wrote this as a transition and then backfilled a simple animator to support ICS and Jelly Bean. This annotation, the not persistent, just says don't ever come back to the screen when the app comes to the foreground. We trigger the screen based on workflow, and we don't want to trigger it based on stale information. So when you come to the foreground, we recalculate again whether you want to see it or not. We don't want it just appearing. We've got one that will kick you out of the screen if you try to navigate to it and you're not authenticated. Instead, you'll go to the login screen. There are some other states that we look for in the user, like whether they're supposed to be working right now or not, and we kick them to appropriate screens whenever this navigation happens. It's useful for a lot of sort of weird state edge cases. We just, in case they happen, go to the right place instead. This one's pretty self-explanatory. You can't press the back button when you're on this dialogue. It's just ambiguous what that would mean on this screen. So we use this in a few places. Pop-ups are modals that appear on their own, and this is already kind of a modal that appears on its own, and it's a pretty high priority one, so we don't want other ones showing up on top of it. This annotation is really cool because it actually takes a priority level, and I can prioritize the pop-ups in my app. So this one wins. It beats other pop-ups and will show up anyway. And then finally, when you navigate to the screen, we want to tell you, we want to report back, call home and say that you did. There are a couple of others. There's a requires location. With other apps we've had require some part of the model, opt out for common rules, redirect to the loading screen, et cetera. Courier screens also nest a Dagger module, which is how they know how the navigator knows where to actually get the configuration for the object graph for that screen. Register is a little more complicated. It's responsive, and it has different tablet and mobile stuff, like not just layouts, but different objects that are at play. So it specifies both modules. And of course, since we're in the activity, we can do stuff like jump to a screen from an intent, which is great for responding to notifications. It's also really, really good for testing. This is the big win here, right? So you fire up a test, you pack an intent that says, I want to be on this screen, and voila, your activity starts on that screen in the app, including whatever data IDs you embedded in the screen. And of course, we can save our place in the app and come back to it, even if the process dies in the meantime. This is what that not persistent annotation was opting out of. So all good stuff, right? We have deep scopes that we can set up and tear down parts of the app. We've got a flat view hierarchy. Even the toolbar got flattened, so we're saving a lot there and simplifying our lives. So we get better performance and don't explode. We have a lot of control over the transitions that happen, and we can do that with varying levels of sophistication based on how much time we want to invest and what platforms we need to support how much. And we have a single navigational controller, so we can apply declarative rules, side effects, set up our animations, and it gives us also a single entry point and state persistence. So what's next? A couple of things. We've written this code, obviously. We'd like to get it out. So there's some updates to some of the libraries we already have coming. I want to pack up the containers I have to do the animators and do the transitions and stuff. Maybe for funsies, write a code generator. The thing I'd really love to see is for this to all be interactive. One of my colleagues on the Square Cache team, Sean Welch, did something very similar on iOS. And because iOS gives you the ability to sort of feed the timeline into the animations very easily, he's able to actually tie all of that to your finger movements so you can scrub back and forth through these transitions between screens. It's very cool, and I'm very jealous. So if anybody has any ideas how to do that, how to wedge the choreographer or whatever, please let me know. But don't wait for me to do any of this stuff, right? These are all fairly straightforward techniques. I've written a decent amount of code to support them, but nothing huge. So you can do all of this stuff in your apps now, if you're not already doing some of it. That's it. I think over time, so I'll have to take questions offline. You can bug me at email or on Twitter, and of course, as everyone else has mentioned, Square is hiring in New York. So please do.